Welcome, Calculus. This is a video on Unit 6, just going over basic integration and some indefinite integration, super basic stuff. All right, example problems, I did them in class. So the fundamental theorem of calculus. I'm doing this at a BC pace, so it should be a review. So that's why I don't go over the details. So there's two ways to read the fundamental theorem of calculus. And it's so I think last time we talked about the second fundamental theorem, where this is like you derive an integral and x is one of the variables, and that's basically derivative integral cancels out, so then it's just f of x, right? Just plug that in. The other part for today is this definite integration part. So if you're integrating from a to b of a function, it's the antiderivative, it's the top minus the bottom. And what does that really look like? So here's my way of writing this here. So let's say I had a curve here, and we're going to call this the curve f of x, right? And you're trying to find the area under the curve from a to b. So the definite integral is written this way. This is a is the lower limit, b is the upper limit. You put this dx thing on the end just because, and you have this like elongated s thing. I think it's an s because of sum. And then your function is whatever in there. So now there's this note of no plus c's, because if you did indefinite integration, which we usually do first, we would talk about how the rules for all that, and then how you have to have a c at the end, because it's a constant. That could be any constant. When you're doing this, the format looks like this. And the way I would actually write that out, wait, I don't like that one. So the way this might be written out would be, let's say the antiderivative of this f is a capital F. Sometimes we do that kind of notation. We'll say is the antiderivative is this, and then we'll write this notation from a to b, and then we can write it as f of a minus f of b, just like this. And I like calling this the I like saying top minus bottom. So the top one minus the bottom one. And we'll do some examples of what that looks like. So that's definite integration. Here's another way this might be written. So what if that function is not f in here? What if it was like an f prime already? So you might, I mean, it's the same thing here, but it's just, instead of making an f and then I have this capital F, the antiderivative of f prime is just f. And f of b to minus f of a. So this is exactly what I just did, except I had f, and then capital F being the antiderivative, and these were capital F's. So you might see it written this way, because I think that's a little bit clearer sometimes, or cleaner. And it's top minus bottom. Integrate top minus bottom. Let's see what that looks like. So a few other things. Who cares about derivatives? So my rules are all over the place. What does it mean to antiderive? Or integrate? We got to go over some of the rules. And the first rule we learn is the power rule. Is this. And you're like, that doesn't even make sense to me. What's with all these n's and stuff like that? Well, here's the way this works. You know how you derive it, and you got y equals like x cubed, and then y prime, we had the rule, you bring the coefficient out, 3, then you subtract 1 from the exponent, right? Well, the power rule for integration is kind of like the opposite of that. So if I said the integral of x to the third power, that's going to be x to the fourth divided by 4. Because the two steps for doing this are step one. I'm going to add 1 to exponent. I had a really nice slide for this one year, and I couldn't find them for you guys. So I just mailed it in for this lesson. You know, sometimes you mail things in because you have higher priorities in life. One of my priorities is John Smith subs. Folks, there's a fundraiser today. That's a week old, but ignore that. And I hope you're there today. I'll be there. Bring your appetite, but mostly bring money. Because I don't care if you just buy a sub and throw it away. It's for a fundraiser. All right, add 1 to the exponent. And then you're going to divide by the new exponent. You know, I could probably just... There. So you had x to the 3. Let me do some other examples. So if you had the integral of x squared would be, I'm ignoring the dx, would be x to the 3rd over 3. What if you had the antiderivative of 4x squared? Well, you just keep the coefficients. That's what things like constant rule mean. So 4x cubed divided by 3. Simplify if you want. Now, what if you just had an x? Well, that would be, that's like x to the 1, so it'd be x to the 2 divided by 2. What if you just had a number like 5? That's like having x to the 0. So that's just going to be 5x. Add an x to the end. Now, one rule with all these is you have to put a plus c at the end of everything. Because think about this, like it's when you, if you had like, you know, how you derive a constant and it goes to 0. But when you integrate that constant, it can go, when you're integrating, we have to compensate for what if that constant was there. So just put a plus c. All right, let's make up some other ones. So other things to note for this. What if you have fractions? X to the 7/3 power. Okay, add 1 to the exponent, so that'd be x to the 10/3. And then you divide by the new exponent, so you might just do this. I think that looks gross. So I like to say instead of dividing by the new exponent, we're just going to multiply by the reciprocal of that, which is the same thing. So I write the 3 over 10. Because you might need to do that to cancel things out, and this looks super gross, and you lose track of things. I do. I don't know, like, I lose track. So I like doing that. All right. What if you had, like, negative exponents? X to the negative 2/3 power. All right. Well, add 1 to the exponent. I'll get x to the positive 1/3 power. And divide by new exponent or multiply by 3 over 1 or just 3, whatever. And of course, plus c. What else could you have? What if I had, I'm going to make up. What if I did a square root? Oh, a few other things. What if I had a negative exponent? X to the negative 2. It's going to be x to the negative 1 divided by negative 1, which is the same thing as negative x to the negative 1, which if you wanted to is negative 1 over x, laws of exponents. And that's where these things get trickier. Like sometimes you'll throw a problem like this, 3 over x to the 5th power. Like don't say, oh, that's x to the 6 over this. Like, don't fall for that. It's, write this as 3x to the negative 5, which is going to be 3 times x to the negative 4 divided by negative 4, which if I'm going to go back in time, I'm going to put negative 3, 4, x to the 4th, and a plus c. Bring it back down. Oh, yeah, plus c. Those are important. So those little tricks. Other common ones. Hey, if there's one slide, this is some common ones that pop up. What's the integral of 1 to the, oh wait, that's, okay, let's not start there. What if we go integral of square root of x? Okay, that's like the same thing as the integral of x to the 1/2 power, which is going to be x to the 3/2 times 2/3 plus c. You know how like the derivative of square root of x, if I said y equals 1 over, y equals square root of x, and then y prime is 1 over 2 square root of x, and that's worth just memorizing. This is worth memorizing. I mean, being very comfortable with 2. I don't know if memorizing, but like don't get tripped up. All right. Other things here. What if I had integral of 1 over x? You're like, oh. So people go, oh, well, I guess it's just x to the negative 1 power. So it'll be x to the 0 over 0. No, don't do that. That's a bad thing to do. That's not how it works at all. So 1 over x is a special rule. This happens in Khan Academy. Is going to be the natural log of the absolute value of x plus c. That's one of those special rules to learn. Now, you can always check it because the derivative of ln or natural log of x is 1 over x. You might ask, do I have to put that absolute value? Yes, technically you do. And the issue is because you can't. Why is it that way? So it's like the graph of 1 over x looks something like this, right? Looks like these two inverse functions. It's weird because there's no zero. You can't just integrate over 0. We actually talk about that in BC, about improper integration. But let's say you integrated from -2 to -1. Well, you can't ln negative numbers. It doesn't work out, but it ends up being okay because of the absolute values making it work out. Make it work out. You can't ln negative numbers. So that's how it works. Just put absolute values there. You're good. What else? Okay, I'm going to go back to my old slides because I think I did all the power rules at this point. Other things I glossed over and that are in this unit. You know how derivative e to the x, z to the x? The antiderivative, integral of e to the x, is e to the x plus c. What if you had bases other than a? I don't think it's in Khan Academy. Integral of a to the x, but it's not. Who cares? We're going to do it right now. Is a to the x, you know how it was times ln of a when you derived it? It'll be divided by ln of a. There you go. Did I miss anything? Scalar rules, sum rules, you don't need these. Trig. So I like remembering when I derive sine, I like drawing the circle thingy. When you derive these, maybe this seems to help people sometimes in calculus. So this is the deriving way. If you follow this arrow, it works in a loop. If you go backwards, that's antiderivatives. Integration, integrals. So integral of cosine of x is going to be positive sine of x. So I'm going doot, doot, doot. Integral of sine of x is going to be negative cosine of x. For these rules, these are, I don't think there's in the Khan Academy, but integral secant, like which of those trig functions has a derivative of secant? That'll be tangent or tanks right here. Secant tangent is going to be secant x. Cosecant. Remember the derivative of, this is going to be cotangent, was negative cosecant squared. So this is actually going to be negative cotangent. When you're dealing with a cotangent and cosecants, you have to deal with negatives here. And so it'll be negative cosecant squared of x. Oh, one thing I forgot in everything. Plus c. Examples. I don't want to. I did these. I'm done. Bye.